Well, in that case, I better get started. Good morning, everybody. Welcome to Cloudy and Earlier Rainy Monday morning with your host, me, Dr. White, in Chem 1105. Good morning. Good morning, Ariba. I hope you all had a great weekend. I did. I got a lot accomplished, including grading tests and other things. If you haven't checked your email, you should have gotten an email with the points for each answer on test one. I'm going to be going through test number one answers in a little while. I will cut them out. I like my special effects, cut them out of the video. And if you don't make it, or if you want to see something again, always feel free to come to my office hours. I'll have my office hour tonight from 5 to 6:15, same thing on Wednesday. And also always feel free to stay after lab tomorrow and I'll answer questions. So before I start going through test number one, couple things. You guys did really good, made me so happy. Thank you. The other thing is a student should never, ever be penalized for a mistake I make in grading. I'll say that again. You should never be penalized for any mistake I make in grading. And guess what? The last time I checked, I don't walk on water unless it's frozen. Even then I stay off it, which means I can make errors. And I do. I try not to, but that will happen. Happens to anybody. If I make an error on grading on a test, email me, I'll check it. And if I made an error, I'll change it. Now, I should point out Monday and Wednesdays are my busiest days of the week. So if you send an email, it may take a couple days before I make that change. And if after a week I haven't, send me a real nasty email saying, you promise to check it. And usually I do within a week or less, but you never know. All right, let's get started. There were two versions, A and C. They're almost identical, but there were some changes or differences, and you'll see. All right, remember, if I made a mistake, you should never be penalized for it. And therefore, email me if I did. And once in a while I do. It's rare, but I do. Just like everybody in life makes mistakes. All right, one of the questions I would have if I were in your position right now, well, I just took the first test. What grade am I getting? Now, I'm assuming you've handed in all the labs. And usually you can forget about the labs if you hadn't, because most of you are doing pretty good on the labs. By the way, make sure you're handing in all the labs. A couple of you haven't, so please do. Because in a week or so, I'm going to be following exactly my syllabus, and you're going to start losing points. Don't. All right. If you got a 90 and above, and a lot of you did, I forgot what the average is. In the upper 80s or low 90s was the average for the class. If you got 90 and above, you're getting, by the way, high score was 99, you're getting an A. If you got 80 to 89, you're getting a B. 70 to 79, C. 60 to 69, D. And below 60, 59 or less, F. Now, I don't think anybody's in that range. I don't think so. But anyways, because of my grading, and the lowest test is dropped, all of you still have a chance to get an A in my course. Now, some of you will have a little harder road to walk, because not always, but most of the time, test number one is the highest average. All right, any questions about test number one? All right. By the way, keep it because it makes good practice problems for the final exam. Wink, wink, hint, hint, say no more. Am I going to put the same problems on the final exam? No, but as my practice problems, and now you understand why I call them practice problems, are similar to what I put on an exam, guess what? On my final, they'll be similar. Let me close a few things here. Oh, one other thing. At this point, I'm going to assume, and if it's not true, email me and I'll help you any way I can. All of you are able to access Beyond Lab Z. One of your colleagues emailed me over the weekend and his problem, which I knew, and that's why I tell you, if you have problems with the access code from the bookstore, email support@beyondlabz.com and they'll help you because they know the bookstore sent out, I don't know why, I have no idea why, uh, outdated access codes. They shouldn't have. They've already been told about that from Beyond Lab Z, but I have no control over them. Tomorrow, guess what? We're going to do another fun Beyond Lab Z lab. It's going to be fun. By the way, it's already posted in the assignment area. If you want to download it, you don't have to yet. All right, let's get back to chemistry. On Friday, I believe, no, Friday you took the test, so that would have been last Wednesday, we started getting into the mole. And just to remind you, the mole is a chemist counting unit, and 1 mole of an element equals Avogadro's number, 6.02 times 10 to the 23rd atoms. 1 mole of a compound, like water, equals Avogadro's number, 6.02 times 10 to the 23rd molecules. Now, remember I taught you, if you have A equal B, then you have 2 ratios you can always write, A over B and not equal, and separate B over A. So if I have 1 mole equals Avogadro's number of atoms or molecules, I have 1 mole of an element equals per, or 6.02 times 10 to the 23rd atoms per 1 mole of an element, or 6.02 times 10 to the 23rd molecules per 1 mole of a compound. And I also have the other ratio, 1 mole of an element is 6.02 times 10 to the 23rd atoms, and 1 mole of a compound per 6.02 times 10 to the 23rd molecules. And before we get into practice time using your good buddy, your good friend, unit analysis, let me point out something important. This is material for test number 2. Let me open it first. If you look in the lecture folder of our class, you'll see important information, test number 2. All right, thumbs up, people. Do you all see that on your screen right now? Uh-oh. Thank you, Amber. Tonight at midnight, I'll be giving speed thumbs up lessons. No, I won't. All right. I used to make students memorize this. And about 2 years ago, I changed that. If you notice right here, I have 1 mole of an element equals Avogadro's number, 6.02 times 10 to the 23rd atoms of that element, and 1 mole of a compound equals 6.02 times 10 to the 23rd molecules of that compound. And this is something I used to say, know this, but let's change it slightly. Hint, know how to use this, because you no longer have to memorize that. All right, it's practice time. And practice helps you on test number 2. Oops, promise not to write. Bad habit of mine. Not bad, just lifelong habit. All right, everybody see the word problem. How many molecules of sodium chloride are in 5.678 moles of sodium chloride? Everybody see that? Thumbs up, people. Wake up. Maybe you can see it. Oh, you can. Thank you. All right, watch closely. First thing, what are you being asked to find? And I don't know where I came up with using a question mark, but you can use any other symbol you want. We're trying to find molecules of sodium chloride. What are we given? 5.678 moles of sodium chloride. Now, once I have this figured out, I never have to look at that again, which makes your life a lot easier on a test and in real life too. So how do I proceed? I use my good buddy, my good friend, unit analysis. I love that whistle siren. All right, this is the only number I have to start with. And don't forget the units. If I had a ratio, what units do I want my answer to be? Well, I have it right here. Now, here's the essence of unit analysis, which will be your good buddy, your good friend in this class, and it has been for many decades for me in general. Whatever I'm trying to get to, the units go on top of the ratio. Whatever I'm trying to get rid of, I don't want these in my final answer, units, goes underneath the ratio. And now I'll put those units above and below. And where do I get these numbers? Where do I get a relationship of moles of sodium chloride and molecules of sodium chloride? And the answer is 1 mole of a compound, sodium chloride, equals Avogadro's number, 6.02 times 10 to the 23rd molecules of that compound, in this case, sodium chloride. So I can go back and say for every 1 mole, I have 6.02 times 10 to the 23rd molecules. Now, anything divided by itself becomes the number 1, cancels out. So moles of sodium chloride, the units divided by moles of sodium chloride, cancel out. Anything divided by itself is gone, comes the number 1. And now the only units I have are molecules of sodium chloride, which is what I want in my final answer. And now I can go ahead, because I've checked it, my units, that I'll get the right units. And now this is 4 significant figures. This is 3 significant figures. And the 1 is part of a definition, 1 mole. Therefore, this 1 is exact number. And when you multiply and divide, exact numbers are ignored for significant figures. This is 4, this is 3. What's the lower number? Hope we all picked 3. So my answer should have 3 significant figures. And now I'll find out where to hide my calculator. There it is. And this is the number my calculator gives me. I'll write it down here. And this is more than 3 significant figures, so I have to round it off, keep the 3, keep the 4, keep the 1, use the 8 to round off. That's, guess what, 5 or higher, so I drop all this, and the true answer, the correct answer, not true, correct, is this. And if you want to put the units, oops, I keep on wanting to write it. And here's my correct answer. Now, on a test, if you don't want to put the units, that's okay. But that's how you do that. Okay, let's try another one I'm going to do. And remember here, let's just go through it first again, because you're new to unit analysis. You're a good buddy, you're a good friend. But before I explain this again, I almost forgot to tell you something. Important announcement from the management, me. Tomorrow, Tuesday, at the beginning of our lecture lab, I will go through problem set chapter 4, part 1. Tomorrow, Tuesday, beginning of our lecture lab, I will go through chapter 4, part 1. So make sure you've tried it already. Sorry about the late announcement, but let's get back to our regular scheduled program. I've never used that again. I might not again. All right, what are we trying to find? Well, for 5 points, I want to find out how many molecules sodium chloride there we go. How many molecules sodium chloride are 5.678 moles of sodium chloride? First, I figure out what am I trying to find, what am I given, and then whatever I have to start with. I put the units of my answer over here. And if I had a ratio, what would I do? What ratio would convert me from my starting numbers to my answer? And you use unit analysis, the red arrow, put the units on top that you're trying to get to, the bottom arrow, the units on bottom, what you're trying to get rid of. Where do I get these numbers in the ratio? 1 mole of a compound, sodium chloride, equals Avogadro's number, 6.02 times 10 to the 23rd. And I put it in there and do the math, make sure 4, 3 exact number. My answer should be 3 significant figures, round it off, and that's how you do it. All right, let me do another one. Oh, let's go to the high rent district. All right, thumbs up, people. Do you all see the problem? How many moles of gold? And in case you forgot, the chemical symbol is AU are 8.765 times 10 to the 15th atoms of gold. I'm going to assume you all can see it because nobody's screaming at me. I can't see it. So how do we proceed? What are we trying to find? Well, moles of gold. And I'm not going to write out gold because I know the chemical symbol. What are we given? How many atoms of gold? And now this is the only number I have to work with. And once I do this, I never have to look at my word problem again. And I have 8.765 times 10 to the 15th atoms of gold. And what units am I trying to get to in my answer? Well, we figured that out already. Moles of gold. And now, if I had some magic ratio, it's not magic, it's chemistry, ratio to go from atoms of gold to moles of gold, how do I do that? Well, you use your good buddy, your good friend, unit analysis. Whatever units I'm trying to get to goes on top of this ratio. Whatever units I'm trying to get rid of go underneath. So I'm going to write the ratio units in. Now, where do I get a relationship between moles and atoms? And let me remind you, if A equals B, you have two relationships, A over B and B over A. So do you know a relationship, in this case, atoms of gold and moles of gold? And the answer is yes. And in the past, students would have to memorize this, but good news, I'm giving it to you in important information. Test number 2, 1 mole of an element equals Avogadro number atoms of that element. 1 mole of an element equals Avogadro's number of the atoms of that element. So now I can put in 1 mole of a compound or of an element is Avogadro per Avogadro's number of atoms. Notice atoms divided by atoms cancel out because anything divided by itself equals the number 1 is gone. The only units I'm left with is moles of gold. And now this is 4 significant figures. This is 3 significant figures. And this is an exact number. So my answer should be 3 significant figures. Because when you multiply and divide, the number that has the least significant figures and not, you don't include exact numbers, is the number of significant figures in your answer. So now I'll put it in my calculator. By the way, if you have mastered using scientific notation in a calculator, come to my office hours, or always feel free to talk to me after class on Tuesday lab. And the number my calculator gives me is 1.45598 and a bunch of other numbers, which I'm going to drop, times 10 to the minus 8. Now, this should be 3 significant figures. Keep the 1, keep the 4, keep the 5. Use the 5 to round off. Is that 5 or higher? Yes, it's 5. So I'm going to drop all this, increase that by 1. And that's the answer, 3 significant figures. And that's how you do it. Now, let's try one where I'm going to let you try some parts of it. We'll do stepwise. All right, the question is how many molecules HCl, that's called hydrochloric acid, we'll learn later that more about that later in the semester, are 5.11 moles of HCl. Now, we're going to do this stepwise. Right here or in your mind, what are you being asked to find? What are you given? You figure that out, and then I'll do it. Time's up. What are you being asked to find? How many molecules? HCl, and you're given 5.11 moles of HCl. Now, why don't you write down what you should start with right there? And I'm going to put in the magic ratio, and why don't you just figure out what units you should put there? You're just supposed to figure out here A and B, what goes unit-wise, a number if you got it, A, and what goes unit, that B looks like an A. Let me fix it. There. Your turn. All right, my turn. What do we have? We have 5.11 moles of HCl. What are we trying to find? Molecules of HCl. why don't you figure out, and I'm going to ask you to do it real quick because we're running out of time almost, what units go on top and what units go there. Not the numbers, just the units. Use your good buddy, your good friend, unit analysis. All right, time's up. Whatever you're trying to get to goes on top the units. The units that you're trying to get rid of go underneath the ratio. And this would be molecules of HCl. This would be moles of HCl. And where do we get these numbers? From important information, or if you have to memorize it, but you don't have to. 1 mole of a compound, HCl, equals Avogadro number of molecules of that compound. And remember, 1 mole of a compound, Avogadro's number, per Avogadro's number. Moles divided by moles of HCl cancel out because anything divided by itself is the number 1. And now I'll quickly go to my calculator, clear it. And my calculator gives me this number. Three significant figures, exact number. My answer should be 3 significant figures. Keep the 3, keep the 0, keep the 7. Use the 6 to round off. It's 5 or higher. Oh, I forgot. I wrote. I was in a hurry. Apologize. And that's how you do it. Oh no, I apologize. I went a whole 30, 40 seconds late. Don't forget, hand in the lab that's due tomorrow. If you haven't handed in some labs, also, don't forget I have my office hour tonight at 5 to 6:15. And with that, I'll see you tomorrow. Gang gesund. Goodbye.